Assalamu alaikum wa rahmatullahi wa barakatuh. The final chapter of AP Chemistry. And today, inshallah, we're going to start with the first part of this chapter, Redox and Electrochemistry. Inshallah, الصوت يكون منيح يا رب. Today, inshallah, we're going to start with Redox and electrochemistry. The first part of the chapter related to oxidation reactions, reduction reactions, how to balance the equations, what's the meaning of the reactions, inshallah, in this video and in the following videos until we are done with the first part. The next part, inshallah, we are going to talk about electrochemistry, electrochemical cells, with types, with reactions, with calculations, inshallah, and then we're done. بس برضو, to remind you, by the end of this course, inshallah, there are videos to solve a whole AP exam, multiple choices and FRQs, inshallah. Let's start with redox and electrochemistry. Today, inshallah, we're going to start with the first part, redox. And next, inshallah, electrochemistry. First of all, what's the meaning of redox reactions or oxidation reduction reactions? At the beginning, Ustaz, scientists defined oxidation, the reaction with oxygen. Reduction, the reaction of substances when they lose oxygen. One more definition, Ustaz. When the substance reacts with hydrogen, so this is considered as reduction. If it loses hydrogen, so it's an oxidation reaction. After this, because those are the easiest definitions for oxidation and reduction. But not all chemical reactions, Ustaz, include oxygen and hydrogen. There are many chemical reactions, oxidation and reduction reactions, and they don't have oxygen or hydrogen. So they needed at that time, they needed a more common definition. Applies for all chemical reactions, all redox reactions. So they set this definition. Oxidation reactions when the substance lose electrons. Reduction reaction when a substance gains electrons. Oxidation is losing electrons, reduction is gaining electrons. Or you could use this abbreviation, oil rig, if you want to make things easier to memorize. Oxidation is losing, reduction is gaining. By the way, can an oxidation reaction occurs by itself without reduction? No, Ustaz, no. Common sense. If a substance loses electrons, there must be another substance to gain those electrons. طب says, can we have a reduction reaction by itself without an oxidation reaction? No way, Ustaz. How? Common sense, not chemistry. You said reduction is gaining electrons. So there must be a substance that loses those electrons. Losing, gaining. Ionic equation, Ustaz, صح? Ionic compounds. Yes, the easiest example, ionic compounds. Magnesium with chlorine. Magnesium loses 2 electrons to have 8 valence electrons. Oxidation. Chlorine gain an electron to have 8 valence electrons. Reduction. The easiest example, Ustaz, of redox reactions, formation of ionic compounds from elements, metals and non-metals. طيب. شوف شو مكتوب. One cannot occur without the other. Oxidation cannot occur without reduction. Reduction cannot occur without oxidation. This is not chemistry, it's a common sense, Ustaz. شوف. Substance oxidized loses electron, or more than one electron, by the way. Substance reduced gains electron. No way to have oxidation without reduction, reduction without oxidation. Let's do some chemical reactions عشان to find out which substance is oxidized, which substance is reduced. Yeah, let's go. بس you know, as a definition, يعني, to start with this chapter, it's easy. Substances lose, substances gain, transfer of electrons, that's it. But in the exam, we need to know which substance exactly loses electrons, which substance gains electrons, and how many electrons. How can we represent this using something called half equations? Let's start. Single displacement reactions. The common type of chemical reactions, redox reactions, those single displacement reactions. When an atom or element displaces another atom or element. This is for sure a redox reaction. طيب. يلا نجهز. It says, do we have calculations هون? No, we don't have any calculations. In the next part, إن شاء الله. يعني في electrochemistry. برضو not too much calculations. Easy chapter to end with. Bismillah. The example says there is a strip of magnesium is added to copper sulfate solution. شوف, I wanted to write the equation, ionic equation, net ionic equation, half equations, find out which substance is oxidized, which substance is reduced. نقول بسم الله, يلا بسم الله. First of all, magnesium, a strip of magnesium, Mg. We don't have different colors. We have this one. Mg, is it good? Wallah, it's good. Mg solid. How do you know it says it's solid? They're saying a strip of magnesium. By the way, magnesium is metal and it's solid at room temperature. Is added to copper sulfate solution, CuSO4, aqueous solution. Single displacement reaction. Magnesium is an alkaline earth metal, a group 2 metal, which means it is more reactive than copper, a transition metal. شفت كيف هاي؟ Magnesium is an alkaline earth metal. Alkali metals and alkaline earth metals are all more reactive than transition metals. So magnesium, شوف كيف كمان مرة, is more reactive than copper. So it displaces copper in its compound. So what are the products, Ustaz, for this chemical reaction? Magnesium displaces copper. So we have the products MgSO4, aqueous solution, plus Cu, copper, solid. Oh, I did this in purpose, by the way. I left everything blank عشان to know step by step, if they ask us to write the equation, to write half equations, to write net ionic equations, عشان to learn them all. And one more thing, Ustaz, إنه magnesium is more reactive. This is to give you some نحكي glances on the reactivity series. Metals, when you compare metals with each other, let's say for group 1 and group 2, group 1 are more reactive than group 2. For group 1 and group 2, as you go down, the group reactivity of the metal increases. If you compare group 1 and group 2 metals, alkali metals and alkaline earth metals with transition metals, they are all more reactive than transition metals. But what about non-metals, Ustaz? Non-metals, the opposite. As you go down the group of non-metals, let's say for group 6 or group 7, reactivity decreases when you go down the group. طيب. Let's write now the ionic equation for this chemical reaction. And I think we did this before, but برضو to refresh our minds, Ustaz. To write ionic equations, we have 4 state symbols given in the chemical reactions: solids, liquids, gases, and aqueous substances. So, if you have solids, liquids, and gases, we keep them the same. The only thing we have to do to write ionic equation, any aqueous substances, we have to break them into ions. And be careful about a small note, write it down. To write an ionic equation, you can write this. You have solids, liquid, gases, and aqueous substances. Solids, liquids, gases, you keep them the same. Aqueous substances, you have to break them down into ions. Except, write this down, please. بالله عليك بنتي يا أخوكي يا أخوكي. Write this down, صديقي. اكتبها على الدفتر. Because they keep trying to trick us using this. This is small note. Aqueous substances, you have to break them down into ions except weak acids and weak bases. شو قصدك أستاذ؟ يعني if they ask you to write a net ionic equation or to find out which of the following is the correct net ionic equation, and this reaction includes a weak acid or a weak base, do not break it down into ions. Keep it in aqueous substances or in aqueous state, or keep the formula the same. Do not break it down into ions. Please, we keep solids. معناته استاذ بنكتب to write ionic equation, we keep solids, liquids, gases, weak acids, and weak bases. Even they are aqueous. Do not break them down into ions. Even if they are aqueous. طيب, let's write down the ionic equation. Magnesium solid, so I'm going to keep it the same. Mg solid plus CuSO4, copper sulfate. You have to break it down into copper ions and sulfate ions. So I have Cu2 plus and SO4 2 minus. Aqueous. طيب. Product side. We have magnesium sulfate aqueous, so I have to break it down into ions. So I have magnesium ions, Mg2 plus aqueous, and sulfate ion, aqueous, plus copper solid, so you just keep it. Easy, wallah, it's so very much much easy. طيب. How to convert ionic equation to net ionic equation? Anyone remember this? متذكرين؟ أستاذ متذكرين. كمان مرة متذكرين. طب how to convert from ionic to net ionic? احكي لي. There are spectator ions in the chemical equation, in the ionic equation, so you have to get them away to end up with the net ionic equation. يا سيدي يا سيدي يا سيدي يا سيدي طلاب الشاطرين. We have to take away the spectator ion or spectator ions away from the ionic equation to end up with a net ionic equation. طب شو يعني spectator ion? What's the meaning of spectator ion? قولي بنتي. Non-reacting ions. يعني those ions that enter the chemical reaction gets out from the chemical reaction with no change. If you notice, sulfate ions, SO4 2 minus في reactants, and we have SO4 2 minus in the product side. So this is the spectator ion. Otherwise, everything is changing. Magnesium solids or Mg2 plus in aqueous state. So spectator ion is SO4 2 minus. That's why we need to write net ionic equation that shows once they ask us, what's the advantage of writing the net ionic equation or writing net ionic equation? Because net ionic equations shows what particles involved in the chemical reaction with no spectator ions. Spectator ions, this sulfate ion, just stay in solution وfind anything positive وبلزق فيه attracted to it, and that's it, and does not change. So it's better to write a net ionic equation. So I have Mg solid plus Cu2 plus aqueous solid ظبط 2 plus أستاذ حاضر 2 plus to produce Mg2 plus aqueous and Cu solid. Now it's very easy to decide which substance is oxidized and which substance is reduced. شوف. Oh, magnesium Mg, I'm going to set here. Mg صارت أو changes to magnesium atom, Mg, neutral atom, changes to magnesium ions, positive charge ion. This is formed by losing ولا gaining? Positive ions أستاذ losing electrons. ممتاز. And في definition, using the definition of redox reactions, oxidation is losing. Reduction is gaining electrons. So magnesium, when it changes from Mg to Mg2 plus, this is the oxidation reaction. Magnesium is oxidized. This is the oxidation. Oh, to remind you, this is losing electrons. No, Ustaz, كمان. How many electrons are being lost? The charge is 0. We don't have any charge here, so I have, and then I have 2 positive charges here. So this is losing of 2 electrons, losing 2 electrons. The opposite. But let me clear this. نامت. pen شوف الحركات شوف 2 plus. Now we have the opposite status. Copper ions, because we have oxidation, so we must have reduction. Copper ions changes to copper atoms. Charge was positive 2, صارت 0. And we will talk about the charges, بس إن شاء الله in the next video. So the opposite is happening here. Copper goes from 2 positive charges to 0 charge. This is reduction. Gaining 2 electrons. Charge was 2 positive, صارت الcharge 0. So this is gaining electrons. Says, can we say if the charge of the substance increases, this is oxidation? And when the charge of the substance decreases, this is reduction? But let me tell you a professional term. If the oxidation number of a substance, of the element, increases, so this is oxidation. So as ما هي charge. مش دائما. If the oxidation number of the substance, of the element increases, so this is oxidation. If the oxidation number, charge between brackets, decreases, so this is reduction. Oxidation number of magnesium, we had no charge on top of magnesium, so the oxidation number was 0. And the oxidation number now is positive 2. Oxidation number increases, this is oxidation. Oxidation number was 2 positive on copper, it becomes 0 on copper, we have no charge, so this is reduction. That's it. No, it's not it. We still need to write half equations. يعني the oxidation half by itself, the reduction half by itself. I'm going to clean the board, write the net ionic equation by itself, or teach you then how to write half equations. Yeah, let's clean the board. We had this equation, the net ionic equation, Mg solid plus Cu2 plus aqueous to produce Mg2 plus aqueous and Cu solid. Magnesium oxidized, copper ions reduced. Please, if they ask you which substance oxidized, which substance reduced, what is the oxidizing agent, we're going to explain. What is the reducing agent? You should not take from the product side. You should not choose any substance from the product side. Substance oxidized, magnesium. Substance reduced, copper ions. Copper ions, huh? Let's write them down. substance oxidized is magnesium metal. Substance reduced copper ions, please, because you might have in the choices Cu ولا Cu2 plus. Which substance is reduced? نحكي copper or no, copper ions. وعشان not to go further أستاذ, when magnesium oxidized loses 2 electrons, giving these 2 electrons to copper ions, so copper ions get reduced. صح أستاذ. So we can say copper ions will not be reduced unless we have magnesium. Okay, صح أستاذ. Which means magnesium is the reason why copper ions get reduced. صح أستاذ. شوف الإنجليش بعدين كيف. One more sentence. Magnesium oxidized because copper ions gain electrons. صح. So we can say, شوف الإنجليش كيف, شوف. We could say copper ions are the reason why magnesium get oxidized. صح. So what I'm trying to say is magnesium is the substance that oxidized, and at the same time it's the reason why copper ions get reduced. So we're going to name magnesium, or to give this name for magnesium, reducing agent. On the other hand, Ustaz, copper ions, they get reduced, but they are the reason for magnesium atoms to oxidize. صح? So copper ions, they get reduced, صح? And at the same time they are the oxidizing agent. Okay, Ustaz, يعني we just switch them. Oxidizing agent is the substance that reduced. Reducing agent is the substance that oxidized. ممتاز ممتاز ممتاز. Oxidizing agent and reducing agent. In this case, sub-oxidizing agent, we can write definition. Let's write definition. The substance, عشان for students who write notes, the substance that is reduced. And here we have the substance that is oxidized. يعني أستاذ بس نعكسهم. The substance reduced is the oxidizing agent. The substance oxidized is the reducing agent. So in this case, Ustaz, substance oxidized magnesium, so it is the reducing agent. وكمان أستاذ, substance reduced copper ions, so they are the oxidizing agent. Copper ions is oxidizing agent. It's very easy, Ustaz. Is this the last chapter of AP chemistry? To be honest, introduction to redox or redox reactions, you should take this before. But my way of teaching AP chemistry, I don't like to cut the chapters each one by itself. يعني redox and electrochemistry. I did this before in this course when we study thermodynamics. We needed to study thermochemistry first of all as delta H, if you remember, and then we talked about entropy and Gibbs free energy with spontaneous reactions because they are related to equilibrium. You need to know about equilibrium. But in this chapter, we have everything about chemistry now. We know every single detail about general chemistry now, or for AP chemistry. So we can take this chapter together. I know it's easy. طيب لسه. We need to write half equations. Half equations, oxidation half by itself, reduction half by itself. Let's write them down. Half equations. Oxidation half. يعني simply I want to represent the oxidation reaction by itself or reduction reaction by itself. That's why we're giving the name half equations. Is it hard, Ustaz? No, it's not. It's not at all. شوف. All what I'm going to do is to say that magnesium get oxidized and changes to magnesium ions. I'm going to write this down as a half equation by giving away or losing 2 electrons. So let's just write this down. This is the half equation. Wallah, Ustaz. Well, Mg solid changes to Mg2 plus aqueous and loses 2 electrons, giving away 2, releases 2 أعطانا 2 electrons. So في الأوكسيدation half أستاذ we should write electrons on the right side of the equation. في reduction halves شوف reduction half. Reduction half. أستاذ والله we know what to do. I know. It's easy. I know it's easy. Reduction half, copper ions, if you notice, خلينا نغير اللون. Copper ions gain 2 electrons. شفت اللفة هاي كيف؟ Copper ions gain 2 electrons and they become copper metal by itself. Cu solid by gaining 2 electrons. So if we wanted to write reduction halves, so we have to write electrons on the left side of the equation as a part of the reactants. So yeah, Ustaz. Copper ions Cu2 plus aqueous plus 2 electrons to have Cu solid. One last note before we finish this video. Be careful. We will talk لسه يعني in more نحكي complicated redox equations and we balance the equations. بس لسه هون because this is the introduction to redox reactions. Be careful if you're writing half equations that number of electrons lost by a substance that oxidized should be the same as number of electrons gained by another substance, by the reduction half. In this case, fortunately, we have 2 electrons. Otherwise, we have to balance. كيف يعني أستاذ؟ يعني if the substance oxidized loses 2 electrons, magnesium. But the substance reduced was not copper ions, let's say was silver ions, Ag plus an electron to produce Ag. وهون أستاذ I have 2 electrons and here I have only 1. So I have to balance. You need to make, and I don't need to make. I'm not going to do AP exam. You have to do the AP exam. أستاذ تتمسخر علينا؟ لا والله I'm just joking with you. بس magnesium losing 2 electrons, silver ions gain 1 electron. So I have to balance. I need to make, you need to make number of electrons being lost the same as number of electrons being gained. So I have to multiply the whole equation by 2. تمام؟ إن شاء الله in the next video بس go تحت قلت لك وكليك to the next video and we will do one more example single displacement reactions وexplain إن شاء الله كمان oxidizing reducing agents solve more questions أستاذ. بعدين we do oxidation numbers. Till then يعطيكم العافية. السلام عليكم ورحمة الله وبركاته. السلام عليكم والسلام عليكم.